For number 11, we are looking at a residual plot here. And to first explain a little bit about what that is, for different values of our explanatory variable x, the least squared regression line gives us predictions for what the y value will be for different values of x. And we actually have actual data from our data set, and that's what's represented by all these points is the difference between those actual data values, what their y values were, and what the predicted y values are from the least squared regression line. And so right here at 0, any point on the line here at 0 would mean that there's a point in our data set that has the same exact y value as the predicted value from our least squared regression line. So the residual is 0. There's no difference. Points above 0 positive residuals would mean that our actual data values had higher y values than the predictions, and points below would mean that our actual data values had smaller y values than the predictions. And what we do is we look at this residual plot to see if a linear model is a good model to use for our data that we have. And the things we want to look for is to see if there's a discernible pattern, something like a curve in these residuals. And there is no discernible pattern here, so we check off that box. That's good. We do not want to see a pattern. Something else we do not want to see is that the residuals are steadily increasing or steadily decreasing as we look left to right. That violates something that is called constant error variance. And here the spread looks pretty consistent across the board. There's no steady increase or decrease. And the last thing we need to check for is outliers. And we actually do have a couple outliers here. And that's something we don't want because that's data in our data set that just doesn't fit the overall pattern of the rest of the data. And so notice all the rest of the data is within a couple lines here from 0, from where our residual is 0, but these are way up there. They're 2 more lines up away from the rest of the data. So that condition, having outliers, indicates that a linear model might not be appropriate for the data that we have here. For number 12, we have a table of data here, and we're looking at the relationship between the time that there is between eruptions of a geyser and then the length of that next eruption of the geyser. And so we have the scatter plot already given to us. And just looking at the scatter plot, it appears to be somewhat in a straight line, so there could be a linear relationship here, and it appears to be going upward, so it would be a positive linear association. And next we want to look at the residual plot to see if that confirms that there is a relationship between these variables. And so the things we don't want to see is we don't want to see a discernible pattern like a curve, and we don't have a pattern here, so that's good. As we move in one direction, we don't want to see the residuals increasing or decreasing. We want them to have a random spread across the board, and that's good here too. And we don't want to have outliers, which would be certain residuals that are way high up or way low down. And again, we don't have that. So we would say yes, the plot of residuals does give us good confirmation that a linear model is appropriate. And the final part is about how to interpret the coefficient of determination. And basically that value is tells us how much of the variation in the y variable is explained by the least squares regression line. And so if we have a given percentage, then the least squares regression line explains that percent of the variation in the y variable. For number 13, we're looking at the weights of various cars and their gas mileage in the city and seeing how those two variables are correlated. And we're given here our correlation coefficient, and we're going to use that in part A when it says what proportion of the variability in the miles per gallon is explained by the relation between weight of the car and miles per gallon. So if it's asking what percent of the y variable is explained by the least squares regression relationship, and I talked about this in number 12. That's measured by the coefficient of determination, which is r squared. So you're going to want to take that value for r and just square it, and you get then the coefficient of determination, which talks about the variability and what proportion of that variability is explained by the relationship. Next, we're going to construct a residual plot. So we look at our data and let's open it up in StatCrunch. And we can go to regression, simple linear. And our explanatory variable X is the weight of the car. The response variable Y is miles per gallon. And you're going to want to go down here to graphs and look at the residuals versus the X values. And when you hit compute then, if you go over to page 2, you'll see a plot of the residuals. And your answer choices down here have a dashed line right at 0 to help make it easier. But you can see the same pattern here from the correct answer choice above, below, above, 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 below, and so on. When you look at the answer in StatCrunch, going left to right with 0, you're above, below, above, 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 below, and so on. So number C, the first part of that's kind of re-asking part A again. We've already computed that coefficient of determination, and what that told us was that percentage of the variance in gas mileage, our Y, is explained by our linear model. And based off our residuals, the least squared regression model does appear to be appropriate. And again, we're looking for, we do not want to see a discernible pattern like a curve in these residuals, and we don't see one. As we move across, we do not want to see the residual slowly increasing or slowly decreasing. We want to see a nice random pattern, so we check out there, and we don't want any outliers, which would be data values that don't fit the overall pattern of the data, and it would be a residual point that's way far above our mark of 0, or that's way far below. And again, we check out, and there's nothing that really stands out as an outlier. And our last one here, we have data on the number of chocolate chips per cookie from a name brand and a store brand. So we want to open that data up here in StatCrunch, and we're going to draw the box plots. So we can go to graph, box plot, and we want them from both of them. So holding down Control as you click, you want both of them to show up over here. And when you hit compute, you'll get them side by side in the name brand one and the store brand ones. First, notice that these are positioned a little different here. Vertical as compared to your answer choices, which are horizontal, so you have to do a little bit of comparison there. But the median value shown with this bar here, you can see the name brand seems to be much higher. Its whole box appears to be higher, and the median's higher. So it does appear that the name brand has more chocolate chips per cookie as compared to the store brand. And for part A, when making sure you get the correct graph, you can pay attention to where those medians are. The name brand came in. Looks like this is 22, 24, 26, 28, 30. So these are jumping by 2. So the name brand's right around 26, and the store brand's right around 23. So if you came back to StatCrunch, you'd see that same thing. The name brand's right around 26. The store brand is looking like it could be close to 23. So that's one way to help line up the box plots and choose the right one. You can also look at the length of the whiskers. Name brand has a really short whisker on the lower end and then longer on the high end, which is what we did see in StatCrunch as well. And so finally then, part C, does one brand have a more consistent number of chocolate chip cookies? So consistent would be that there is a tighter, smaller box, so most of the cookies are falling into a consistent, similar value for the number of chocolate chips they have. And this box is smaller for the name brand than the store brand, and the store brand also has much longer whiskers, which shows that there's data where some cookies have a much higher number of chocolate chips and some have a much lower, where everything's just more compact and shorter on our name brand here. So there is evidence that the name brand is more consistent as well.